Let's take a look at how to find the probability when we have a normal distribution, such as SAT scores. And we know that the mean SAT score is a 1083 with a standard deviation of 194 points. If we randomly select a student who took the SAT for this year, what is the probability that the student's score is greater than a 1200? In other words, find P of X greater than 1200. So I typically tell students to begin by making a sketch of a bell-shaped curve, like what I have on the right-hand side here, and then identify the mean value at the center of your distribution. So put that at the center of the bell-shaped curve. Now I'm going to show you two techniques, one using z-tables and two using the graphing calculator. So let's first start with calculating z-scores. Let's mark where 1200 is on this distribution. So that's somewhere between 1083 and a 1277. So I'm just going to mark it there. So that's x. X is 1200. And I want to find the probability that a randomly selected score is going to be higher than 1200. So we're going to shade the area that is to the right of this marking because the area to the right represents all SAT scores that are greater than 1200, okay? All right, so now we are going to first ask ourselves, what is the corresponding z-score that goes with an SAT score of 1200? So we can do that calculation. Let's find the z-score. That's x minus mu over sigma, so that's 1200 minus 1083 all over 194. So if we do that calculation, we get a z-score of 0.60. And that makes sense because we expect that z-score to be between 0 and 1, which it is. Okay, now we're going to go to the z-table, so let me pull that up. And we're going to go to the positive side of the z-table and search for a z-score of 0.06. So hopefully you're following my cursor here. It's this row right here, and it has a corresponding area of 0.725, so 0.725, but remember the z-table always gives you the area that is to the left of that z-score. So this 0.725 is going to be the area to the left. So let me go back to our little sketch over here. That means that this area that is to the left, right, has an area of point, and I already forgot, what did we say? 0.725. 7, okay? But we want the area that's blue, the area to the right. Now we know that the total area under a probability distribution is always equal to 1. So if I want to know the blue region, then I have to take 1 and subtract the region that's to the left, which has an area of 0.7257, and that'll give me the area that is the blue region, the area on the right. So that gives me a probability of 0.2743. So this blue area here is 0.2743. So this tells us that P of X greater than 1200, the chances of randomly selecting an SAT score greater than 1200 is 0.2743, or that's approximately 27.43%. So that's how you use the table. Now let's talk about how we would do this on the graphing calculator. So on the graphing calculator, I'll do it on the right-hand side here, you're going to use the function normal CDF. And normal CDF is going to ask you to put down your lower limit, your upper limit, the mean value, and the standard deviation. Okay, so remember that this is a continuous function, so this line goes on and on. So for an upper bound, you want a number that's very large. So you can type in 1E99 on your calculator, or you can type in a very, very large positive number like 999,999. So I'll show you how to type in 1E99 as your upper limit. Here, our lower limit is that 1200. So again, you're writing down the limits that bound that area that we shaded in blue. So 1E99, and then you're going to write in mu, which is 1083, and then write down the standard deviation, 194. So let me show you where you find that on the graphing calculator. Under this button called VARs, right above it in blue is distribution. So you're going to press second VARs. It's going to take you to your distributions. And you're going to choose option 2, which is normal CDF, which stands for normal continuous density function. Okay, so we're going to choose option 2. And your calculator is going to prompt you to put in your limit. So let's type in 1200 as our lower limit. And then I'm going to type in 1. And to get the E, do you see the little comma button right here? Right above it is double E. So you're going to press second comma, and you'll see it'll show up as one little capital E there. And then press 99, and then type in the mean value 1083 along with the standard deviation value of 194. And then move the arrow key down and then press enter. And then here it'll show you what you typed in for normal CDF. Press enter again, and you'll see here that it gives us a value that is very close, if not exactly similar. Okay, so it's pretty close to what we got using the Z table. All right, any differences would be due to rounding errors. Okay, so because we rounded our Z score, that affects this value, so that is where you see the difference. Okay.